All right, let's get started. So we've got a lot to get into today, so let's just jump right in. First, a bit of a recap from yesterday's lecture that Tommy gave, lecture in the workshop. So first we have HTML. Whenever we're designing a website, one of the core features, one of the core components is the HTML. This section describes the content and the structure of the website. It tells us what exists, it tells us where it is, it tells us how everything is organized across the page. The second component that we discussed is the CSS. So this is the presentation of the site. It talks about colors, it talks about the alignment. We talked about Flex, which is a very powerful tool, and we'll see more of that later on. And so these two are, of course, super useful, and you'll see that on really any website you visit. But if you just have these two together and nothing else, what do you get? You get a nice, pretty looking website, but it's static. It just sits there. You read it, but you can't really interact with it. You can't really do anything more with the site. So that's where JavaScript comes in. JavaScript is what we use to manipulate the content of a web page. In other words, it's what we use to take the HTML and the CSS that we already have and make it interactive. The user can click with their mouse or press keys and interact in those fashions to actually have the page respond to them and do things. Because of this, JavaScript is super popular. It's used everywhere. Like the vast majority of websites, web applications you've used probably have JavaScript in some form because it's one of the primary languages we use to achieve this sort of functionality. If we take a look at just a snippet of JavaScript code, don't worry about what this does. We'll go into all of that. But if you're coming in from another language, you'll notice that this feels a little more. It kind of has the vibe of what you might call a standard programming language, as opposed to HTML or CSS. This really does feel like it has that sort of like programming logic, and we'll see how all that is implemented. Speaking of other languages, though, do note, I just want to point this out off the bat, JavaScript is not related to Java, in case you had that impression, which seems like it would make sense based on the name. They are not at all related. Just keep that in mind. So since it is a programming language and there is this degree of code, where does that actually go? Where can we run it? One option is what we call the browser console. You can try out these keyboard shortcuts on your own browser. Just pull up any website and press the corresponding shortcut. So in Chrome, it's Control-Shift-J. Let me here. There we are. So something will pop up on the side. Depending on the website, you might see a bunch of errors. You can just right-click clear. Don't worry about those. That's Google's problem, not mine. Yeah, feel free to pull it up on your own, and you can run code here. This is the same thing that Tommy pulled up for the HTML, except his was in the Elements tab, and now I'm over here in the Console tab. The other way we can run the code is tied to our HTML file, which we'll see how to do later on. But before that, we'll just jump into the pure JavaScript side of it, how we actually get stuff to happen in JavaScript. To start off, JavaScript has 5 primitive data types. By primitive, we just mean the most basic level. So we have Booleans, which are just true or false. We have these things called numbers, which are what they sound like. This is anything, positive, negative, 0, integers, decimals. JavaScript does not distinguish between types of numbers. There's also strings, which are, as the name suggests, strings of characters. We denote these using quotes. Double or single is fine. I'll stick with double quotes for the whole presentation, but you're free to use either. Including strings of digits, which are different from numbers, and say this empty string. Here, this empty string is just the string without any characters. It's still a string because it has quotes. Lastly, there are these two types, null and undefined. There is a difference. They sound similar, but there's a difference, which I'll talk about in a bit. The first thing we can do with these sorts of values is we can apply operators to them. So what are we talking about here? We're talking about things like arithmetic operators. These are addition, subtraction, multiplication, division. You can run these in your console. If you have the console up, just try random operations. You can just use it like a calculator. Everything works the way you'd expect here. You can also do things like adding strings. What this means is just concatenating them, sticking them together. along with the arithmetic operators, we also have what are called comparison operators. These are what we can use to check if two values are equal, not equal, less than, greater than, things along those lines. And it will tell us whether it's true or false. Something you might have noticed when this showed up is the triple equal sign at the top here. If you're coming in from another language like Python or Java, you're probably wondering, like, I'm used to this being a double equals. I'll discuss why it's triple equals in JavaScript uh, somewhat towards the end. The single equals, however, is used for variables. So for those unfamiliar, a variable is just a name we assign that we can then like give some data value. If you've seen variables before, that concept is familiar. What's new here is this keyword let. In JavaScript, when you first use a variable, you have to declare it. You have to tell the program, I want this variable to exist so I can give it a value. In JavaScript, that command is let. So we can do something like let my boolean equal true. Once we've done that, we've already declared the variable, so we can freely change its value. Later on, we can say set it to false, and its value will update. So don't forget to use let the first time a variable comes up. Just from this snippet of code, there's a few things we can already note about JavaScript convention and syntax. One of them is that we use camel case to name our variables in JavaScript. So by camel case, we just mean that every word is capitalized except the first one. It's kind of like a camel that has one or more humps. The other thing we note is that every line, every statement ends with a semicolon. This is what we use uh, to tell the program, this statement has ended. I'm going to move on to a new command now. There's things being mentioned in the chat about var. I will discuss that in a moment. So I will discuss that briefly in a moment. There's more to look into if you Google it, but yes, so that is coming up. While we're on the topic of variables, though, I want to mention something called constants. So JavaScript has these things called constants, which we denote with this const instead of let, which we use to define a variable that cannot be reassigned later. So here we could declare a variable answer to life, which is we declare with const and set it to some arbitrary value. And then later on, if we try to reassign it, it will fail. The program will shout at us. It'll say, you're not allowed to do this. And so constants prevent anything from changing later on down the line. This little green line here with the double slash, it doesn't really look like code. It is because it's not really. It's what we call comments. In JavaScript, we denote comments with double slashes before the line. So these don't affect how the code runs, but we like to put them because it keeps our code organized. It lets anyone reading our code know what's going on, so that they don't have to sit and think for an hour about what this block of code does. So do use comments whenever it makes sense to annotate your code and explain what's happening. All right. So I mentioned const about how it forces something to not change later. So why would we use that though? Like it seems more restrictive than let. So why bother using it in the first place? Any thoughts on that? Why might we use const? Feel free to just send it in the chat or something. Yeah. Yeah, see a lot of good answers. Yes, so basically the whole idea is that we don't want things to change if they shouldn't change. I have not actually taken that class. SFB, what? Safe from bugs? Is that what that acronym stands for? Yeah, something along those lines. So yes, the reason we use const is safe code practices. If something shouldn't change, we should just make sure it doesn't change. Just declare that off the bat. For example, we might have a conversion factor, which would make our code cleaner instead of just tossing random numbers out. we might have defined a variable to do so, something like seconds per minute. This better not change during our program. If it does, there is something wrong. So we can just say off the bat, don't let this value change so that we can use it safely later on without worrying about that. Questions on that? Again, if there are questions, probably best to direct them to the questions doc so that you can get the most prompt responses on those. I said I was going to discuss null versus undefined real quick. So JavaScript does have both of these values, and they sound like they would be similar. Undefined here means that you've declared the variable, but you haven't yet given it a value. So everything's default. These default values are undefined. If you just do let first name and you ask what value it has, it is undefined. I can then assign it something, say, well, my first name. And then if we want to clear it, we should use the null command here. We should use the null command when we want to clear a variable because we're like explicitly stating we want this to be emptied. That makes sense? What's going on here? All right. Yes, and as Nick says, please put questions in the questions doc so Puka Puka is happy. Puka Puka the turtle. Is he still crying? I'm a little sad. All right. On. Yes, so this has been asked a few times in the chat. Some people who have used JavaScript before, or if you've looked up JavaScript code online, you will often find that there is code written using var in place of let. Var just stands for variable, and they use it to declare variables. So you will find code snippets online that use this, which is why we bring it up, because what's the difference? What should you use? Short answer is don't use var. Let used to just not exist, and now it does, and you should basically always use it in place of var. I won't go into technical details just for time. You're welcome to Google it, but basically it's just that let was introduced in large part because var had unexpected behavior and people ran into bugs when trying to use it. So let is now used, and let behaves probably the way you'd expect variables to behave, especially if you're coming in from other languages. So we would just recommend using let. If you find code online with var, try replacing them with lets. If it breaks, figure out why. Try to avoid using vars. Right. Questions on that? All right. Moving on to some other topics. One thing we might want to do in really any language is provide some sort of an output. So in JavaScript, one of the ways we do that is we use what's called console.log. And so this happens in the console. You could just try this command yourself right now. It's just console.log, and then in parentheses, what you want to log to the console. And it does exactly what it sounds like. It just prints whatever you had back out. Now, you might be wondering, why would you use this? Here it looks kind of trivial because you inputted it and output it in the console. If you put it in the program, in your script, it will show up in the console. But when's the last time you've had to go to the console to interact with a website and have to read something there? Probably not often. One thing you could use it for is um, maybe some quick debugging. So you could have a variable in your code that takes on some values, and you want to check, is the value correct here? And if you open up your website, then it will log in the console what the value is, and you can check, okay, is something right here? If you've ever, say, written something in Python and had the joy of debugging something by putting a print statement on every other line, we don't necessarily encourage that technique, but it is an option, and you can do something similar with console.log. While we're on the topic of outputs, there are many other ways to provide some sort of output so that the user can more readily see it. One option is called an alert. And so an alert just generates a pop-up notification. You've seen these all the time in your browser. And so this just shows up with the text that you give it. We'll see this used a few times later on. So just mentioning this because to tell you that it is an option. All right, questions on that so far? Okay, so the next thing we're going to go into is the topic of arrays. So right now, up till this point, we've just worked with these like primitive data types, the uh, most basic types of data. Here, we're going to start kind of combining them into larger, more complicated structures. An array is used when we want to store some sequence of usually related or similar items. In JavaScript, like in a lot of languages, we use these square brackets to denote an array and separate the elements with commas. So here I can declare a variable pets, let pets, and here it's equal to an array of length 4. It has 4 different animals you might have as pets. So this is what we have to do to create an array. Once we've done that, we can do a number of things with it. For example, we can access elements of the array. So here we have that uh, we've taken this syntax means take the index 3 element, you index into the array, uh, retrieve that, and console.log it, so output it. So what is this output? Any thoughts in the chat? What will show up when we run this? The way feel free to put your guesses in the chat. There are, in my opinion, 2 reasonable guesses. If you're familiar with JavaScript and if you're coming in from most other languages, you are probably going to guess bird. So why might it be guinea pig? Because the third element in the array is guinea pig, so that would make sense. But JavaScript, like most other languages, is what's called zero indexed, meaning that the first element of the array is actually index 0. And so in this case, cat is index 0, so bird will be 3. So just keep that in mind. JavaScript is zero indexed, unlike certain other unfortunate languages. So do keep this in mind as you work with your arrays. Now, that being said, you can use a similar syntax to replace elements in an array. In this case, we can index into the index 2, which is the third element, guinea pig, and we can just sort of put that on the left side like a variable and assign it a new value. And so this will just update the array that we already have. So this will feel familiar to people who have worked with arrays in other languages. It's a very, very similar syntax. We can do many other things with arrays. One of the most obvious things that would come to mind is, what if I want to add something to the end or remove something off the end? The command for removing we call it pop. So you just take the name of the array and run .pop parentheses, and it will just chop off the last element. At any point, we can also add something to the end with what's called push. And so you can just imagine you're like pushing something onto the end and then you're popping it off. That's just how we talk about it. And in this case, we can push rabbit onto the end of the array, and pets has now been updated and is now 1 element longer. There are lots of other commands you can run on arrays. So I will talk about a few more of those later. Yes, one question in the chat is regarding types in arrays. Right here, I have an array of all strings. JavaScript doesn't prevent you from mixing types in arrays, as far as I'm aware, but you shouldn't, based on the idea that arrays generally contain things of the same type. So even though it doesn't prevent you outright from doing it, there probably shouldn't be a reason to mix types in arrays. Right? Cool. So pause quickly for any other questions at this point. And again, of course, there's always the question stock, so feel free to ask anything there. All right, I'll move on for now then. Or is that questions? Is there a way to force the type of a variable? Yes. So in pure JavaScript, no. There is something called TypeScript, which Shannon will talk about, I believe, next week, which is a type-safe version of JavaScript. But for now, we're not going to worry about that. All right. So going into some more things you can do with JavaScript, you can often perform different, or you often want to perform different actions based on like certain properties that your variables might have, or certain things being true or false. And so in JavaScript, we use the keywords if, else, and else if. Uh, this reads almost like English. You ask if something is true, then you do whatever is between these curly braces here and here. And so you define this block and say everything inside here will happen if this statement is true. Otherwise, else, if this is true, then you do this block. Otherwise, if this is true, then you do this block. Otherwise, do the thing at the end. And so this is how we write this conditional statement in JavaScript. If you're coming in from Python, note it is two separate words, else if and not elif. So if you're used to that, I guess it's a bit of a habit to break once you start writing JavaScript code. One thing I did mention here is that these curly braces denote this block within which like all the code to be run goes. Like you have a block here that starts here, ends here. You have a block that starts here and ends here, and so on. Because of that, um, even without indents, you should be able, like the program should still know like where to start and where to end. So the indent's not strictly necessary, but you should still use it, just because it makes your code a lot nicer to read. If you're coming in from Python, you're already used to using indents all over the place. So uh, hopefully that is already a habit for you. In general, it's just good coding practice. It keeps things organized. All right. Another control flow, so we say, option that we have in JavaScript is what's called a while loop. And so while loops we use that runs a certain body of code as long as some condition is satisfied. A super simple example we might see is we start with some variable, and as long as it hasn't hit a threshold, we apply something to it and output it and repeat. So in this case, what we're doing is we're just doubling z, and then we're printing it, and then we just go back and keep doing it until the condition is broken. So, I mean, what is this output? I just see if I can get one or two answers before. What is this output? Where does it start? Where does it end? Yeah, so it's going to output powers of 2, right? Because you'll start with, what happens is z starts at 1. So every time it doubles it, outputs it, goes back. Does it output 1024? It does, because when it hits 512, it'll double it and then output it, and then it'll go back and ask, has it now broken the barrier? So it does the entire block of code, goes back, and then asks, am I still satisfying this condition here? So note the syntax on this. If you're coming in from another language, you'll just want to get used to the way that JavaScript code looks, so you're familiar with that. There's always these parentheses, there's always these curly braces. Another control flow option we have are for loops. So for loops are useful when we want to go through or iterate through some list of indices. For example, if we have an array. So this is the same array from before. I've just made it constant this time. No big difference. And so here we have 4 elements, all strings. And the for loop works as follows. I have this index I. At the beginning, it's 0. That's what this first chunk here means. This last chunk over here, I++, means it's a shorthand for like every time I go through the loop, I will increase I by 1. If you're coming in from, I guess, like Java, this feels very familiar. If you're coming in from Python, this is very new. So take a note of how this functions. So you have this index I. It starts at 0, increases by 1 at every step. For each value of I, we're going to do what's in this block. In particular, we're going to construct a phrase that has a string and indexes into the array, pulls the ith index element from this guy, makes this big string, and outputs it. goes back, increases I by 1, does it again, and keeps doing it until it hits this limit, the length of pets. So what does this print? I think this more or less gives it away. It will output to the console 4 strings, 1 for each element of the array pets. As you can tell, I like my animals a lot. Yeah. Any questions on how this works? Yes, do note the syntax on this, especially if you're coming from a language that does not really use this sort of format. Again, parentheses, again, curly braces. All right. Could I have made phrase a variable? In particular, could I have made it a non-constant? Yeah. There's no real reason or I should put this like phrase. I made phrase a constant here because it can be constant. Within this block, I created phrase, but I didn't change it again within the block. Once I go back to the start of the for loop, um, the idea of phrase has just vanished because I'm on a new loop. And so I can create a new phrase. But every time once I create it, I'm not changing it. So I just decided to make it constant. You could use let and it would function just fine. All right, moving on. So JavaScript, like really any other language, has what are called functions. So the syntax for this is we have parameters, which are the inputs to the functions, and we use an arrow to take it to a body, which within the body, it does a bunch of whatever computations it needs to. It might then return something, which is our term for outputs. If you've used JavaScript before, you may have seen other ways to write functions. We're going to stick with this one for consistency, but but there are other ways you could do it. This is kind of maybe a more modern option. So here, what we're doing is we're creating a function. We're going to name it Celsius to Fahrenheit. So we declare a function. And this section starting at the temp C is this syntax up here. So temp C is our single parameter. That Celsius temperature is our single input. If there's only one input, these parentheses don't matter. So don't worry too much about that. But here we have an input temp C, and we take it to some body here. Inside the body, it constructs a new variable, a Fahrenheit temperature, using this conversion formula, and then it outputs it, it returns it. So this is how we define functions, and note that we gave it this name, Celsius to Fahrenheit. Once we've done so, like right now we've just created the function, but we haven't used it yet. So now we can actually call it and give it some value. The syntax here for inputting a value into a function is just like in other languages or in math. We have the name of the function, parentheses, the argument, the value that we give to the function. And here we run Celsius to Fahrenheit on 10 as our Celsius input, and it creates some output for us. And then we log that. So it should output 50 if you check the math in the formula. Right. That makes sense. Any questions on that? Why isn't temp f a let? Yes. So this is a similar question to the what we were looking at here with the for loops. Inside, I made it a constant because I could do that. I wasn't changing it later on. Same thing with this guy. Every time I run the function, I create this temp f that I don't need to change again throughout the entire function body. So there's no reason for me to make it a let. I chose to make it const because, again, safe practices. Again, it's not, you could have used let and it would have worked fine. But throughout all of this, I will use const whenever it is possible to, just to keep it safe. Right. So we'll note from this example that we define Celsius to Fahrenheit in a way that is looks a lot like a variable. Like it's just const Celsius to Fahrenheit equals stuff. That's how we defined variables. It could have been let, but in this case, it's constant. So that suggests to us that we can sort of toss around functions like any other variable. And this is true in JavaScript. In particular, we can take a function called a callback function, and we can pass it as an argument into another function. So this is could be a little confusing. We're kind of like 2 layers in now. We have a function that we've defined that takes in an input, returns an output, and then we pass that into another function as an input. It's a little confusing. Why might we do this? Seems a little weird, this nested behavior. Here's an example. Here's an example of how we might use such callback functions. First, we have this add to function. It's super simple. It does exactly what it sounds like. It takes in this input x, and then in the body, it returns x plus 2. That's what add to should do. Now, this is where the meat of this topic is. It's in what's called this modify array function, which takes in 2 inputs. It takes in an array, and it takes in a callback function. And inside of this block, this is a for loop. I'll just translate it into English. What's going on is that for every index, it accesses the ith index in the array. It runs the callback function on it, and it updates the array. So it sort of edits the array in place by applying the callback function to every single element. Now, why is this useful? We can run something like this. If we have an array, let's call it my array, and right now we start it with the values 5, 10, 15, 20, then we can run modify array on this array using the add to callback function. And so inside of this function body, the modify array function, it says, okay, whatever this callback function is, that's what I'll apply to every element of the array. Once we're out here actually running the function, we can specify what that function should be, what we should actually do on my array. This structure is nice because maybe later on we want to modify a different array with a different callback function. We can still use the modify array large function, but just feed it a different array and a different callback function. So this structure wouldn't have to change in the slightest. We can reuse this with a different array, different callback function in any combination we want. So that's why this sort of a thing is quite useful. We're introducing it because it will be the core of a lot of functionality you'll see in JavaScript and in React, which we'll go into tomorrow. I believe it's tomorrow, yes. And so we're introducing this now because you'll see it a lot, this idea of a callback function. So because of that, because you use it often, we're just going to point out right off the bat a common mistake that is made. So remember that in the previous example, add to is the name of the function. And so when we ran modify array, we had to pass add to into the as the callback function argument. Whereas something like add to of x is the value that gets returned if you were to run add to on the input x. So this is what we often see, something like this, where people will run pass add to of x into the argument. That is that might feel like that makes sense, maybe from a math perspective. We like, oh, f of x is the function. In this case, the name of the function is add to, so that's what we want to pass in. Modify array needs to actually be given the name of the function in order to use it when it wants. So be careful about this. This is a common mistake that is made. So remember, all you're giving here is the name of the function. Does that make sense? Right. Yeah, questions doc seems to be overloading, same with yesterday. If in the meanwhile, I guess you could direct questions to the Zoom chat. I will try to answer until questions doc comes back up. So this is the same example we saw on just 2 slides ago, the add to modify array. Note though, I mentioned that this function is super simple, right? It literally just takes an input and it adds 2 to it and returns it. And we use it just once down here. So the question then is, did we really have to go into the hassle of naming it and then using its name? Not really. There's a thing you can do in JavaScript, which are called anonymous functions, so-called because they don't have a name. And when you need to use a function, if you don't already have it, instead of creating it and assigning it a name, you can just create it on the spot and then use it where you need. So in this case, it's the same add to function as before, but we're going to create it on the spot and just feed it directly into the modify array function. So this is an option if there's a function you only need to use once, and it's simple enough that you can just pack it in like this. If your function's even simpler, in this case, this function is really simple. There's an even shorter shorthand you can use, which is instead of doing this whole thing with the arrow into like curly braces in the body, you just map input to output. So x arrow x plus 2 will do exactly what you want as well. We mentioned this because there are cases where this sort of comes in handy. If they need to make a super simple change to an array, just like add 1 to everything, or like perform a simple operation on everything, this sort of callback function, anonymous callback function, comes in handy. All right. Yes, so question, this is a good question. Is a callback function always necessary when trying to use a function in another function? So what we're looking at, for example, is this guy. I have a callback function, and I fed add 2 as the argument. This is not, oh, it depends what you mean by necessary. What this structure is nice for is that I can use it later on to pass any function I choose at that moment to use as the callback function. If I were to just use add 2 in here right off the bat, like explicitly say add 2 for callback here, it will always use add 2 regardless of what the input is. I like this structure because I can choose what function I want to give it at any point in time. Hopefully that makes sense. Right. I mentioned that there are other things you can do with arrays. And if it's common enough, there probably is a built-in for it, just in general. We've seen push and pop, which edit the target array in place, shorten it, increase its length. There are also these things called map and filter. So map and filter, I'll talk about what they do, but they will, at a high level, they will create a new array based on some instruction we give it. And this instruction is going to be a callback function, which is why we just went over those. So what do map and filter actually do? Map creates a new array by applying the given callback function, the one that you feed it as input, to every element of the array you're running it on. So this feels very similar to what we just did, except it creates a new version of the array. So if we have some array called myArray, here's 1, 2, 3, 4, 5, we can run myArray.map and have the function take input x and output 3 times x, and it will create a new array that applies the same function to every element. It maps the function onto the array. So we can do something maybe a little more complicated. This is the Celsius to Fahrenheit function from earlier. And using this, we can have some Celsius array, just 5 temperatures in Celsius, and we can run map on it where we apply the conversion function to every element. And it creates a new array, which we call Fahrenheit, that should have the right values. It should convert every element using the function. So that's what map does. Filter works a little differently. Filter goes to the array and it selects the elements that pass the given condition. So here our condition is that it should be true. It should work if the input x is greater than 0. So we can take some array values here has bunch positive, negative, has a 0. And if we run filter on it, it will filter out the bad values and it will only keep the good ones. So filter can be useful in these cases. Maybe a more practical example might be if we have a list of names of staff, or I mean people in general, but in this case it's a list of some of the web lab staff, except some of the inputs are like bad inputs, they're empty strings. So we can filter out the bad strings by saying, okay, a name is good only if, or a name is good if it's not empty. And if we do so, then we are only left with the good names. So this is maybe a more practical example of this is maybe a more practical example of where filter comes in handy. No, all the staff were great, Claire. Don't worry. All right. Questions on that? All right. Again, questions doc. I think they made a second doc, so just direct your questions there. I'll move on for now. The next topic to discuss is called wait. We don't have a primitive data type for this. So what are we talking about here? If we want to store data in our program, if we want to store a number, that's fine. There's a thing called number in JavaScript. But if we want to store something more complicated, like this idea of a car with a bunch of properties, we don't really have a thing for that automatically. So we construct what are called objects. So in JavaScript, an object is it's a collection of properties, and each property has a name describing like what that is, and a value saying like this specific object, like what value does that property have. So if we're just describing the car on the previous slide, we can talk about a few things. We can maybe talk about its make or its model, what year that model was. We talk about its color. Obviously, there are many other things that describe this car. We'll just stick with 4 for now to keep it simple. Note the syntax here. There's curly braces. We love our curly braces in JavaScript. And then we use these colons to separate name to value. And we have a comma to separate each property from each other. So we can list as few or as many things we want to describe whatever type of data we are trying to store. So what can we do with this? Well, the most natural thing we might want to do once we have an object is to access its properties. We want to know, given an object, like what values does it have. There's 2 ways to do it in JavaScript. One way is with this syntax here, which is like the name of the object dot name of the property. So my car dot model will give you the model of the car. Or you can access it kind of like an array, but with the name of the property inside the square brackets. If you're familiar with Python, this is like a Python dictionary. So you can access it sort of like that, and you can get the value as well. 2 ways to do it. Use whichever makes more sense in context. If they both seem to make sense, just pick one. Now, there are cases where you might want to access a lot of properties at once. And so there's a shorthand that helps us with this. So take a look at what we might do if we wanted to access both the make and the model and store them. Here, what we'd have to do is we'd have to like say const make is mycar.make. The model is mycar.model. There's a shorthand for this, which is called object destructuring. And the syntax just looks like this. It's just something, you can always look it up afterwards. No need to memorize everything here on the spot. But you just, inside curly braces, you just name which properties you want and let it equal my car. It doesn't have to be every property, and it works exactly the same as this left side. It's a nice shorthand. You'll see it sometimes. We would recommend using it just because it's functional. It keeps things nice and compact. So use it if you have the opportunity. All right. One way we might use objects, so we should find some way to actually put this to practical use, is that we can treat objects really like any other variable. So if we have a list of cars that have these same 4 properties, make, model, year, color, we can create an array of them, and then we can do something like apply a filter. We've learned how to use filter already. So we can just keep the cars that satisfy some property. In this case, we only want to keep the cars whose colors are red. And then we're left with some array we call red cars. That is exactly what it sounds like. So you can get creative with how you use objects. There are many things you can do with them. And so just you can just explore the options you have there. They are just another variable, albeit a little more complex. While we're on the topic of objects, though, there is something that needs to be brought up, which is the question of equality. So in JavaScript, we use the triple equals, as mentioned before, to check if two primitive values are equal. So we can have 2 equals 2 is true, 2 equals 3 is false, and something like 2 equals string 2 is false because they're different types. So it checks if they're the same type, same value. But what does it mean for arrays and objects? In case you think it's obvious, I mean, maybe you actually do already know the right answer, but I will give an example of what might happen. Let's say we have 2 arrays. You all can see this console, yes? Good. All right. Alrighty. So let's say we define an array 1, 2, 3, and then let's say we define a second array with the exact same values.
Could you zoom in a little?
Can I zoom in a little? Question. Yes, I can. Yeah, I just realized that was a little small. Yeah, okay. So, so we have 2 arrays. I've defined them to be exactly the same. They have the exact same contents, same length, same everything. So, naturally, they should be equal. And we just, it's like, just check that. Uh-oh, that's maybe not what we want. These 2 arrays look identical, but they are in fact different according to JavaScript. So we actually see this behavior. You can try it out yourself in the console. We see this behavior for arrays. We also see it for objects. If 2 objects have the same properties with the same values, they're different. What's going on here? What's happening is, I mean, some of you maybe already be familiar with this concept, but the idea is that these object variables are what's called references. So when you create an object or when you create an array, anything more complex, it creates it somewhere off in memory, and the variable is just a pointer. It says, okay, I'm going to point to where it's stored in memory, and that's all I'm going to care about. If you access its properties, it has to like think, okay, I'm pointing there, so I'll go there, and then I'll find the properties. But when it's just sitting around, all it knows is where it's pointing to. If you create 2 objects, both with the same name, it creates 2 separate objects in different places in memory, and each variable points to a different spot. When you use triple equals in JavaScript, it checks if they're pointing to the same spot. It checks if the references are equal, meaning that 2 objects created separately have to have different references because they're 2 objects sitting in different spots in memory, even if they have the same contents. So keep this in mind, object equality may not work the way you think. Same with arrays. An array just gets placed somewhere in memory, and so 2 separate arrays point to different spots. So JavaScript says they're different. Primitives check the actual value, numbers, strings, booleans. Anything more complex like arrays and objects, check these what are called references. If you have any questions on that, feel free to toss in question stock or ask me later. I'm going to speed ahead just because I don't want to run out of time. The issue with references is one of the issues that might come up with this whole idea of references is the idea of copying things. So it's not as simple as what's here. You create an array, 1, 2, 3, and then you just copy it over. I want to create a new array that has the same contents, so I just say copy array equals array. Why does this not work? What could go wrong? Yeah, a lot of people are mentioning have the correct idea in the chat. So let me actually try this out in the console. We can attempt something like this, where we will create an array. So for those of you who haven't seen this before, note what happens here. We create an array, and we create a copied array, which we're just gonna, say, just let it equal the old array. We have a new copy. Now we can change, so array is equal to 1, 2, 3. copy array is also equal to 1, 2, 3, just like we want. Now let's say we want to change something about the copied array. Let's say we want to change its second value, index 1, to something random like 10. Copy array is now 1, 10, 3. Great. But array is also 1, 10, 3. That maybe not what you want. They should be separate arrays. So what happened? A lot of people in the chat already described it correctly, described what would happen. But it's that the issue, before I go into that, the issue is that when you say array equals 1, 2, 3, you're putting an array in memory and you're pointing to it. You're saying, okay, that's where this array is stored. When you say let copy array equal array, you're putting a second pointer that points to the exact same thing. You're saying that, yes, I want to point to the same guy. So if you edit that, both variables are pointing to the same array. So they'll both see the changes. Usually that's not what you want. When you make a copy, you want a separate copy that behaves separately. One way we do that in JavaScript, again, there are many ways to do this. One way is what's called a spread operator, this ... You can think of it as sort of unpacking all of the contents of what comes after it. So if you have an array called array that has 1, 2, 3, you can create a copy by unpacking it, ... array, and putting it inside of a new array. So down here, we unpack array and put it inside of a new array. Same thing with objects. If we have an object with some property, we can unpack it with the spread operator and stick it inside of a new object. So it just extracts all of the contents and creates a new object with those contents. This is good because it's no longer pointing to the same guy. You really did create a new object somewhere in memory. Right? Yeah, I mean, you could do something like just copy over the elements one by one, but that might not be the best option in a lot of cases. So we would recommend using the spread operator if it makes sense. Right. Something I mentioned briefly before, I'm just going to go over briefly now, is this double equals, which you might want to use if you come from other languages. But this is why we don't use double equals in JavaScript. Here, this behaves as expected. 2 equals 2 is true. 2 equals string 2, false. However, if we use double equals, they're both true. 2 equals string 2. What's going on? JavaScript does a thing called type coercion with double equals, meaning it tries to force them to be the same type before checking them. Here it will be like, okay, I'm going to turn this number into a string and see if the strings are equal. That's not what you want usually. Numbers and strings are not equal because they're different things. So probably don't use double equals. Just keep that in mind as you're going forward. One last topic on the pure JavaScript end. I'm going to speed through this because this is already a complicated topic as is. The idea of classes, if you've worked particular in something like Java, you've probably seen this a lot. These are like objects, but with a little more structure. You can guarantee multiple things have the same sort of behavior. So you can have this idea of a rectangle, has a width and a height, and this constructor tells you how to build one. You just input a width and a height, and it gives it stores its own personal values for width and height. Once you've done so, you can access its properties using this dot width, this dot height. You have these things called methods, which for any example of a rectangle, you can run these sorts of methods to run functions on itself. Different rectangles will have different areas because they have different widths and heights. So you can guarantee that any example of a rectangle has this get area function, has a width, has a height. So it provides some more structure. I am just breezing through this because the idea of classes is a very elaborate topic, and there's no way we're going to get into any real amount of depth with it here. It's kind of something you could probably just take a class on in and of itself. So feel free to ask questions later on if you ever find a use for it. I think it'll probably show up when you start doing React. For now, don't worry too much about this topic. What matters more for us is how we actually use JavaScript to interact with our web page. This section will be shorter, I promise, so hopefully I won't run too far over time. But what's going on here is we want to figure out how to actually use everything we've learned and get our website, our web app, to do things. How do we get the JavaScript to interact with the DOM? DOM here just means how our browser interprets this tree of HTML elements, like these nested boxes. It's a term we're going to toss around, so just so you're familiar with it, we'll leave that there. So there are a few things you need to add to your HTML. This is where we start talking about tying the JavaScript into your HTML. The first thing is IDs. Remember, Tommy talked about this yesterday, about how IDs are unique identifiers to elements in the HTML. In CSS, we like to style with classes a lot. In JavaScript, IDs are usually pretty comfortable, so we'll stick with IDs here. You also need to add a script tag ideally at the end of your HTML file. This index.js is the name of the JavaScript file, the JS file, that contains our code. That we'll talk about what sort of code goes in there, but make sure this is like in the same directory and contains the code that you want. So it's this sort of a tag, script source equals file name. So once we've done this, what can we do? The first thing we probably want to do to interact with our website is to find an element. If we have something on our site, we need to be able to access it from the JavaScript. This is a function that sounds like it does exactly what it should. Document.getElementById. The input is just the name of the ID, and you can assign it a name. So in the JavaScript, I have created this header div, or I've assigned this header div to be this chunk of stuff in the HTML. So why is that useful? Because once I've done that, I can modify what's in it. So here's another example. I have a paragraph with an ID, content. Once I know that's in the HTML, I can find it using document.getElementById. And then I can change its inner HTML, what's contained inside of this paragraph. And if I change it to some string, it will update. It will change the HTML. It will change what is shown on the browser. Note that it doesn't go back and like permanently edit the code you've written. It just changes what displays on the browser. So if you were to like refresh the page, it goes back to the old HTML, reapplies the JavaScript, and does that. So it's not a permanent change in your source code. It's just what your browser ends up rendering. Right. There are, of course, many other things you can do with JavaScript. There's a lot of things. I'm going to list a lot of things off right now. You don't have to memorize all of these because we will have a workshop later that will actually try all of these hands-on. Something else you can do is you can affect the style. So this is the same paragraph as before. We access the paragraph using this document.getElementById, and we can change its style. In particular, if we want to affect its color, we have this content element, the paragraph. We go to its style, we go to its color, and we can set it equal to, in this case, red. And the output, what you'd expect. It changes the text color to red. Now, another useful aspect with JavaScript is that you sometimes don't want to change what's there. You don't want to change something that's already there. You want to add new things. So we have here UL, the unordered list, is just like a bulleted list with two items, list items, milk and cabbage. You can access it using document.getElementById, same command. Now this is the new part. We can create a new list element with document.createElement. This input is what type of element we want to make. So we've created a new list element. We've assigned it some content, in this case, apples. And right now it's just a new element floating off somewhere in memory. We want to actually attach it to this shopping list. So it's list.appendChild, whatever the list was called, .appendChild, and attach this new element. And what does that do? It attaches a new list element to the end of our unordered list. So this is how we would add elements in JavaScript. We can do something more complicated. This is the same thing as before, but now with more things we want to add. We need to add more things to our shopping list. How can we do this? We can run a for loop. This is going back to what we learned earlier. We can run a for loop, and for every item in this need to buy array, we can run some function on it that does all the work for us. This content is exactly what was on the previous slide with adding a new list item. Except now we're going to run it on every element in need to buy. And this will do exactly what it sounds like. It will start with whatever list is there, and it will just take every element of this array and attach it to the end of the list. Cool. Now that's all well and good, but right now what that does is when you load the site, it will just make all these changes instantaneously. And we didn't really see anything happen. We didn't really interact with the page. This is where JavaScript becomes really powerful. We can attach what are called event listeners to HTML elements and make things interactive. They can listen for things like clicks, double clicks, dragging an element around, pressing a key with key down. The way this works is that we have some element called, let's call it button. We can find it, document.getElementById, by ID, and we do button.addEventListener. This first term is what we're listening for, in this case, when you click the button. And this last guy is a callback function. And in the body of the function is what happens when you run it. So this is a pretty simple example. And what it looks like it does is it should create an alert when the button is clicked. It's a pretty straightforward thing. I just have an example of it here. I think you all can see this. Click the button, and a little alert pops up. That's all that does. But what that shows is that we can have elements listen to something that the user is doing. There's another way to do this. There are fields that go like on click. You can do it this way as well. These will be on the slides, so feel free to use either way. We would recommend add event listener probably. There are many things you can listen for. I think I went and counted for you all. There's like at least 80 different actions you can listen for the user to do. So quite a lot. It's a little bonus. Sometimes you don't want to listen for when like a button is clicked or something. You want to listen across the whole page when someone presses a key anywhere. What we do here is we attach something to what's called window. So window is the whole browser, all of its contents. We can add an event listener to window. It's the same syntax, window.add event listener, what we're listening for, a key press. And we can we can do an output. You press this key. In this case, we have an input. The event is just what key we pressed, and we can log what key gets pressed when we do this. This will show up in the workshop, so don't worry if this didn't make too much sense because you'll see a practical example of this sort of thing. Window just exists. You don't have to worry about like doing let window. It's there, kind of like document. You can combine everything we've done so far, interactivity along with what we've learned with just pure JavaScript. This code, just to break it down super quick, we have a div that contains some paragraphs and a button that says add a paragraph. And inside, all that's happening is the button listens for a click. Whenever it gets clicked, you just run add paragraph and create a new paragraph. The add paragraph function does everything we've talked about. You create a new paragraph element and you attach it. You add it to this div. You append a new child. And that will do exactly what the button suggests. It will just add new paragraphs every time you click it. If you refresh the page, it doesn't save anything. It just reboots the HTML and you can toy with it again. Of course, this is a bit of a toy example. Will you have something on your site that you just click a button repeatedly and have a paragraph pop up? Maybe not. Maybe you will, maybe not. But listening for these sorts of events, I think, is what makes JavaScript super useful. And we'll see a more practical example after the break. For now, just to go over what we can do with JavaScript. We can add these elements sort of on the fly. Like whenever we need them, we can just create something. We can add it inside the document. We can change its contents and we can change its style. We can affect how it appears. And lastly, the most important part, we can make things interactive by attaching these event listeners. And so we can listen for things like clicks, we can listen for things like key presses, and we'll see some examples of how we can apply all of this in a workshop after the lunch break, which Daniel's son will be running. But yeah, so if there are any questions on anything, on anything from this, feel free to send in the chat. I'll be hanging around, but also in the questions doc. And yeah, that's all I've got for you today. Are there any last questions? Yes, as Shannon says, be back by 3 when we'll start the workshop promptly around then. All right, ran a little over. Thanks, y'all, for sticking around. See you all in a bit.